Alright, so this video is going to show you how to use the measurements that you made on your poster board, and using the thin lens equation calculate both the image distance and the image height. So first we're going to use the thin lens equation, which is going to allow us to solve for the image distance. You'll see on the screen I put the measurements that I made in the previous video. My object distance was roughly a positive 36 centimeters because it was on the left side of the lens. My object height, since it was upright, is a positive 7.5 centimeters. And then my focal length was a positive 15 centimeters, and I know it was positive because I'm using a converging lens. Again, if you need help with figuring out whether your values are positive or negative, make sure you email me. And then you'll notice that the thin lens equation is also on the board, where it's 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length. I'm going to show you how to use this equation and rearrange it, because it tends to throw students off simply because if you notice the image distance is in the denominator's place. We cannot leave it like that. So we have to rearrange the formula in order to use it. The first thing we're going to do is move 1 over the object distance to be on the other side of the equation, and we can do that by subtracting the fraction. So this would cross out, and we would now get 1 over the image distance is equal to 1 over the focal length minus 1 over the object distance. And then we have to consider the fact that the image distance is in the denominator, and in order to do that it would be almost like taking having to multiply both sides by the image distance. So let's say I were to multiply by the image distance, and these would cross out, and I would have basically 1 over the focal length minus 1 over the object distance in parentheses multiplied by the image distance. And then I can actually move that whole piece of information in the parentheses underneath the 1 by dividing it. And that's what I want to do, because I want the image distance to be by itself. So I'm going to divide both sides by this whole thing here. And ultimately what I'm going to get is the image distance is equal to 1 over the focal length minus 1 over the object distance in parentheses. So that means I have to do the mathematic problem in the parentheses before I were to divide 1 by whatever it is. So now I'm going to plug in my numbers that I have measured on the previous video that we did. Whoops. So I have the image distance is equal to 1 over 15 centimeters, which is positive, minus 1 over the object distance, which is also positive, or 1 over 36. Now when you mathematically go through this, you can take 1 divided by 15 and then subtract the answer of 1 divided by 36. It's entirely up to you. I am one where I like to keep my fractions as fractions until I'm done. So if I go through and multiply, I would get basically like 36 over 540 minus 15 over 540. Because I'm basically making my denominators in my fractions the same, and I do that by multiplying 15 by 36 and then multiplying the 36 by 15. But it's entirely up to you. Ultimately, if you go through the problem, you should get an answer of roughly maybe 25.6 or 26 centimeters if you were to calculate this out. I tend to round up, so I said it was 26 centimeters roughly for my image distance. And that's one of the calculated answers that we need in order to do step 5. Now you can also double check your work if you look at your poster. Now if you didn't calculate it right, you're going to have some goofy value that might not make sense. With my image distance, it was 36 centimeters going from the center of my image here to the center of my lens. And then it's 26 centimeters from the center of the lens to my image. And it is positive, even though it's on the other side, it's going to stay positive, and that's because it's telling me it's a real image. It's not telling me what side of the poster it's on, really. Well, actually, technically, real images are going to be on the right side. So excuse that. But the real image piece is the part with the sign that you're going to get. So I have a positive 36 centimeters telling me I have a real image. And, you know, if I look at this and let's say I didn't calculate it right, or I left the image distance underneath the 1, I would get a really small decimal number, and that wouldn't make sense based on my ray diagram and where the converging rays were found. So you can always double check that on your diagram. Now when I went through and measured out my image distance, I was a little off from where my rays converged. That's fine. A little bit off is not a big deal. So if you find that your image is not as far over as, say, your intersection, which mine was kind of right there, that's okay. They're relatively close. It could be anything from using a small ruler, not having parallel lines, not having 100% straight lines, or just making a mistake measuring. So just make sure you don't overly freak out. Now, if you are off by a significant amount, then that would be a little concerning. So we found our image distance. Now we're going to find our image height, which is the last piece that we need to do in order to finish step 5. And I'm going to write down the values that I need to know. So I need my object distance, which is still positive. I need my image distance, which we just calculated. And I need my object height. And again, it's positive because my image is upright in my poster. So those are the values that I need because I'm going to use the magnification equation in order to solve this. Now the magnification equation looks like this. So I have my image height over my object height is equal to negative image distance over object distance. And I don't have to have the m there. That's the trick with this, and a lot of times students will miss that. M is just the magnification. We can use m and heights, or we can use m and distances, or we can actually just use this portion of the equation, which is what we're going to do. Now you'll notice that I have the image distance and the object distance, and I also have the object height, which means I can solve for the value I'm looking for, which is ultimately my image height. Again, we have to rearrange this equation, and we can do that by multiplying both sides by the object height. And that will get rid of that. And it'll give us our image height by itself, which is what we need in order to solve for that. All right. So that's ultimately what my equation is going to look like when I'm calculating the height. And since I have the image height by itself, I can now plug in my values. So I have that negative image distance, which is 36 centimeters. And that, again, for me was positive, times my object height, which is positive because it's upright, divided by my object distance, which was 36 centimeters. So I plugged my values in, and if I go through and calculate this, I will get roughly 5.4 or 5.5 centimeters. Now, the trick is I have that negative value. I have to keep it. So if I stick with 5.5 centimeters, this negative value here is telling me that my image height is negative, meaning it's inverted. And again, you can check this on your poster just looking at your ray diagram that you drew before. And you'll notice on my poster board, my image is inverted, meaning my arrow's pointing down. It's upside down. So that makes sense. I calculated that correctly. And if I go to measure on my actual poster paper, it's really close as far as height goes. So that turned out really well. Now again, when you're done calculating these, I do want you to write your values on the top right portion of your poster. So you'll notice in my picture here, I have my object distance, object height, my focal length, my image distance, and my image height. All the answers are on there, as well as the correct symbols, positive or negative. And then you can write what type of image you would make, which would be whether it's real or virtual, if it's inverted, upside down, or if it's up, right side up. And then also tell me if it's larger or smaller. So in this case, my image would be smaller because my object height was about 7.5 centimeters, and my image height is 5.5 centimeters. So I have a smaller inverted real image in this case. And that's going to complete step 5. And in step 6, we're going to draw it again. Again, if you have questions, make sure you email me. Otherwise, I hope this helped you use the equation to figure out the values that you're going to need to write on your poster.